Welcome to this session.
This next session demonstrates the practical implementation of CQRS using modern Java features, showcasing how this pattern improves code structure, maintainability, and data access efficiency through a real-world example application. Our speaker is a programming architect at 72 Services LLC. He's a Java champion, Vaadin champion, and Oracle Ace Pro. With 3 decades of experience in software architecture and development, he is passionate about increasing the efficiency of full-stack development with Java. When he's not lecturing at universities or speaking at international conferences, you might find him sharing insights on his blog. Let's give a warm welcome to Mr. Simon Martinelli.
Yes, hello everybody. Welcome to my talk about CQRS. Maybe first, as an introduction, what will we talk about in the next 45 minutes? I will talk about client-server communication. So usually in today's application, you have a single-page application framework like React, Angular, or Vue, for example. And then you have an API on the server side or on the backend side with some business logic and database access. And in a recent project, I had issues because developers tend to develop such applications on the backend side in a naive way. So they go ahead and just implement the application logic, and then they put an API in front of it with DTOs and stuff like that. We will see that in a minute. So I created an example application. There's a GitHub project. You will find the link later. And there we have 2 projects. One is called CQRS. That will be the result of my talk. And there is another project, it's called Traditional. So this Traditional project is a Spring Boot application. And this Spring Boot application just has some entities. So let's start with that. We have a purchase order. It's all mapped with JPA annotations. This purchase order has a reference to a customer, which is also an entity. And the purchase order also has a list of order items. Now we have an API for that. We also have a repository for sure. So that's a traditional JPA repository from Spring Data. And we have an API. So the API is a class called order controller. It's a REST controller from Spring Boot. It has a dependency to some repositories, and it uses a model mapper. Model mapper is a mapping framework that is based on reflection. You will see that. And on the other side, you could also use MapStruct, which is maybe more popular. The difference is MapStruct is generating code. It's more powerful, and Model Mapper is more basic. But for my example application, Model Mapper is just fine. So let's have a look at when we want to get the purchase orders. We will have like a first name. We have last name as request parameters, so we can filter by first name and last name. And we also have some paging information like the page number and the page size that we don't get the whole database. So what we do there, we have a finder method. It's a very long one, find all by customer, first name, ignore case, like, or customer name, ignore case, like, with first name, last name, and also the page information. And then we get back purchase orders, and we stream through the purchase orders and map them with the model mapper to a DTO. And the DTO is more or less an exact copy of the purchase order, so it has also a customer order DTO, it has an order item DTO, and the order item DTO has a product DTO. So if we continue with that, we also have like a post method where we can create the purchase order. We use the exact same object here. First, we check if we find the customer, then we set the customer on the purchase order, and finally we save it. And if we want to change anything on the purchase order, we just issue a put mapping with the exact same purchase order DTO. So that's something I see very often in my projects, and there are some issues with that. So let's get back to the presentation. What I call this naive way of implementing REST APIs, I call that the mapping of waterfall. By the way, the picture on the right side is the only AI-generated code or AI-generated stuff in my whole presentation. But because everybody is talking about AI these days, I decided also to add some AI. So here we have the waterfall, and I think Dali created a very nice picture for my presentation. So what's the mapping waterfall? The mapping waterfall is the same as we've seen before. So we have a REST controller that uses DTOs because we don't want to expose entities at the API layer. Then we use a mapper. In my case, I used object mapper, and this then maps to an entity, and the entity is sent to service. In my case, I don't have a service. I use directly the repository because my example application is so simple. It doesn't make sense to add an additional layer, and the repository stores the data to the database. So that's fine. So it's also based on, if you look at Spring Boot tutorials or whatever, that's kind of how we do this. If you read data, the same thing happens. So you also call the REST controller. The REST controller then goes to the repository, fetches entities, and transforms the entities with the mapper to DTOs, and the DTOs are the result from the GET request. Now, let's start with this GET purchase order method. The application is running here, and I created the file. It's a requests HTTP. I don't know if you know that, but if you're using IntelliJ, then you can create a file called whatever with the extension HTTP, and this will turn into an HTTP testing file. So maybe use Postman, for example. It's similar to that, but you can just write the get method here with the 3 hash signs. You can do a separator and also add some documentation. Here, for example, I say traditional get orders, and then I have the request. So I do a get request on the orders endpoint, and first name and last name, in my case, are empty. And I just say, give me 9,999 purchase orders. That doesn't make really sense, but I just do that to show you a small problem. So if I run this request here, it takes a while, by the way, and you see it takes a bit more than 3 seconds. So for sure, we load way too much data, but why does it take so long? So if you go to the output, we see a lot of SQL statements, and let me check how many statements these are. So we created 4,951 statements just to get our orders. So the problem that we face here is also based on the way we implemented our application. It's so-called N+1 select problem. That means that we select just the purchase order. So let's get back to the controller. And the purchase order here is then mapped by the model mapper. And by doing that, the model mapper accesses all the dependencies in the purchase order, and that will cause a reload of the data because our purchase order, if we have a look at that, we have a list, and lists or one-to-many mapping in that case are by default lazy loaded. So they are loaded when the getter, in my case, of the items dependency is called. And then we also have in the order item a product that is also lazy fetched. And by that, it generates this n+1 select problem. In my case, it even is an n+1 select problem that creates the issue with these statements. So that's something that you typically have, and you should turn on SQL logging by default during development, that you see these problems if you test your controller, for example. So let's go back to the presentation and check out what we have as issues. So we have two issues. The first issue I call too much. So by just having one DTO, this purchase order DTO, we are probably overfetching. So we are probably fetching too much data that we may not need. So we don't distinguish between post, put, and the get method and use all the time the same DTO. This is probably not the way to go. On the other hand, maybe not all data can be changed. So if we have a look at my DTO, you will see the DTO also includes, for example, the ID. So now if I get the data, having the ID in the content is fine. But when we want to update the data, probably that's not a good ID because we cannot set the ID. And the user of our API will not know what to do with the ID. And if we just map stuff one by one, we could have potential bugs because we don't really care about how it is mapped. And on the other hand, maybe the mapping is not correct, so we have a typo, and then we will have a problem. In my case, it's even worse because there's no distinguish between the model and the DTO model, so it's more or less the same. We anyway expose our domain model to the API. And the other issue that we have is too little, so I call it too little. We have maybe something like underfetching. So maybe if we have an API that has more than just a few API endpoints, as in my example, we may have multiple requests to read data from the API. And this will cause an n+1 select problem on the client side. And this is even worse than with the database because usually you have more latency between the browser and the front end and the back end, and not as or more than from the server to the database. And on the other hand, you could have an even worse problem. It's called understoring. So maybe you have to do update and inserts in multiple requests. And because you're on the client side and don't have any distributed transaction, this will cause maybe a problem, and you will have to get around the problems that you have if, for example, the second insert does not work. Now, the solution in my case, or what we introduced in the project, because we were facing exactly these issues, we were looking around and found that we could use CQRS. CQRS stands for Common Query Responsibility Segregation, and is a pattern introduced by Greg Young, and then later described also by Martin Fowler, and was inspired by CQS from Bertram Meyer. And CQS means Command Query Separation. And Bertram Meyer was introducing Haskell programming language. And what he said is a method should only write data or read data, not do the same in the same method. So if we have a look at this picture, by the way, that's a picture from the original document from Greg Young. You find the source link in the footer of the slide. And many people just have this picture in mind. So CQRS seems to be very complicated. You have eventually consistency. You need two separate data storages to make that work. And that's not entirely true. So CQRS means query and command separation. And you can do that simple. So if you use CQRS or how we did that, you could also start very simple. So that means instead of having a single DTO and a single entity model, we have two models. So we have a command model and we have a query model, and this will help to add understandability to the application. It also helps to add readability, because if we look at an example, we would not have a post request and a get request, but we would have a command that's called create order, and we would have a query that's called find orders. So that means when we look at the code also on the client side, because for example, we could use OpenAPI and then generate the OpenAPI specification from our code, and then we can generate the client access code for our single page application, for example, also based on the OpenAPI specification. Then we will not find endpoints that are get and post and put, but we will find commands like create order, for example. And this also improves the readability on the client side. That's a very important fact that we get if we do that. Now, if we look at the command side, the question is how we can do that. And my talk is called CQRS with Modern Java. And for that, I used some of more modern Java features. A lot of people are still on Java 8 or on Java 17 maybe, but Java evolves very fast lately because it has this 6 months cadence now, and you get new and exciting features every half a year. So the first thing that I use, and I use extensively, it's called Java records. Java records are immutable data structures. And as you can see here, it's not a class, it's a record, and it directly has kind of the default constructor parameters besides the record definition. So we have here an add item command, for example, and what we send here is the order ID, the product ID, and the quantity. So we no longer have a DTO that holds all the data we want to send back and forth. We just create a command with minimal data that is needed to execute the command. Then another thing that's very handy, we will see that in the demo, is called sealed classes. Sealed classes is a way to restrict interfaces or classes from being extended or implemented. For example, here we have a sealed class shape, and we define that only circle, rectangle, and square is allowed to extend shape at all. This not only has a benefit for the definition of the shape in that case, or the commands, we will see that in a minute, but it also has some implication, for example, based on the switch expression that can check if all the subclasses, for example, are used. Then the switch expression is something that is very useful in my application, because in contrast to the switch statement that we had before, the switch expression can yield a result. So here in my case, we have a switch over color, then we have red, green, blue, and the switch statement checks, the switch expression checks if all the colors are used in the expression. Otherwise, you will get the compilation error. So that means my color is a bit limited. It just has red, green, and blue. And then we have, with the arrow sign, we can then have the return value or the yield value, which will be red, green, or blue. And finally, what we have something called pattern matching. Pattern matching was first introduced for instance of operators, so you can have a variable after the case here in the switch expression and use that one directly without having to cast, for example. And finally, this was also combined with the record pattern finally in Java 21, so that you have kind of the structure of a record in the pattern matching. So for example, if you have an instance of for a pair, we directly can define the parts of the pair or the attributes of the pair and directly access then left and right as a variable in our code. So this is comes in very handy. So let's have a look how I implemented that. The CQRS application is split into command and query side on a package level. And on the command side, we have an order command. And the order command is a sealed interface. So that means we have the interface order command. And then I permit to have create order command, add order item command, and update quantity command. I use inner classes or inner records in that case in the interface just to have a kind of a namespace. So that's not how you must do that. That's just a way how you could do that. And then we have the parameters. For example, create order command uses a customer ID. And what I also added here is bean validation or Jakarta validation, just to add some direct validation on the command side. When the command comes in over the API, then bean validation will validate my command directly. Then there is an add order item command and an update quantity command, just with the minimal data that is needed to execute the commands. By the way, I've got something to say. Very often the question is, what is the difference between a command and an event? The command is a request. So that means here we have create order command. That means I want to create an order for a certain customer in that case. But this means that command can also be rejected. So for example, if the customer ID is not found, then no customer order will be created, for example. On the other hand, we have events, and an event is something that already happened. So that means an event is also written in the past form. So if the create order command is successful, we can issue an event that would be order created event, for example, or order create would be the name of the event. So usually create order command is in the present form, and then the event would be in the past form. Now we have these commands, and the command handler here is then straightforward. We use the switch expression, and here you can see that we have cases for all commands, and we also have the destruction, so the pattern matching for records that we use then to create order in service or add the item or update the quantity. Now, switch expression is exhaustive. That means if I, for example, go ahead and say, okay, let's add, for example, delete order item command, and then we need the order item ID, and this implements order command as well. Now, the problem is first, this is not allowed because I just allow these types here. So this means I would have to add this here as well. And then if I do that, the command handler also has a problem because the switch says not all possible input values are covered. So I can add this, and then I have the delete order command as well. So that's the benefit of using this switch expression and the sealed interface that I have here. That's the way it goes. Now, that's for the command side. And how could I improve the query side? The query side, as we saw before, has a different model. So I use the same database here, as I said, because you can start simple. But maybe I will not use the same path in my application to read and write. And for that, I use a framework called Juke. By the way, you can do everything also with Hibernate. It doesn't really matter. But Juke has a feature that I like to show you that is very helpful if you want to read nested structure as a result of your REST API. What is Juke? Juke is a way to use SQL in a type-safe and compile time-safe way. So Juke has two parts. It has a DSL that reminds of SQL. And on the other hand, you have the Juke generator that generates a meta model in form of Java classes based on the DB. Why do I choose Juke? Because commands often are just insert, update, and delete. So I can use Juke to generate minimal updates. But on the command side, if you're into domain-driven design, for example, you can just use your domain model with whatever mapping framework at the end you will have. But on the query side, sorry, I often want to return nested structures. For example, in my case, the order has an order item, so that's a nested structure. And Juke has a superpower. It's called multi-set value constructor that lets you exactly do that. So let's go back to the query side. And first, what we want to do is, I also have a request for the CQRS part, so to get the orders. And if I start that, let's have a look at how this works. And you see, we also have a lot of data because it does read 1.5 megabyte of data, so way too much. But in contrast to the traditional way, it's much faster, so it's more than 3 times faster to get the data. And if you look at the application, we see that there is only one SQL statement generated. So there are two, but that's because Juke usually logs the query first with as a prepared statement. So we have this question marks here, and we also have the feature that it logs the query with inline parameters that you can use then, for example, if you want to execute that in a SQL tool. Now, how is this even possible? First, we have a look at what Juke generates. So Juke is very often used with test containers. So I use test containers to spin up the database. Then I have Flyway scripts to for the database migration. They will be applied, and then Juke will then generate the code based on the test containers database. It always depends on your setup. You could also directly generate the meta model from the Flyway scripts. That's also possible. But there it's a bit limited in terms of features that you can use there. Or if your database is huge, you may not start it for the generation. You may have a reference database that is running, and then you can generate this based on this reference data. But in my setup, which is very common for smaller or medium projects, even test containers realize that this is a very common way. And Siva from the test containers team created the test containers Juke CodeGen Maven plugin. What does this do? First, it starts a test container, so it needs to know which database that I use. In my case, I use Postgres. So I just say Postgres. That means it will then start the latest version of Postgres. That's probably not what I want to do. Usually I want to specify the version. And then I have to say that I want to use Flyway. It also works with Lickybase, by the way. And because my Flyway scripts are in the default location in the file system, I don't have to tell anything. So this plugin already knows where it is. And then I have a Juke element where I can define what should be generated. So I have an input schema, for example. I also can exclude elements, for example, the flyway schema history table I don't need. And then I can say in which package it should be generated. There is a bunch of other configuration. I could create the data access objects, POCHOs, bean validation annotations, a lot of stuff. So if you're interested in the Juke generator, go to the juke.org and read the documentation. It's very well explained there. And if I run that, we can just do that to see what happens. It first starts test containers. Then test containers is looking for Docker on my machine. Then test container starts a reuk container. Reuk means that's a management container from test containers that is used to start and stop the created containers. And then it will start Postgres. And as you can see, that works pretty fast. So Postgres starts in just 1 second. And then the reddish printout is flyweight that is applying the migrations. And then we have Juke that is introspecting the database and finally is generating um, the objects. And here you see what you could use to generate. So there are a lot of stuff that you can switch on and off, and it found 4 tables and 4 sequences to generate. And this is generated into generated sources in the target directory. And what Juke generates, it generates a class per table. So that means we have one-to-one representation of the database objects in our Java code. And we will have this constants here, like purchase order, that's the name of the table. And we will also have, for each column, we will find a constant that we can use to write our SQL statements. And that's what I mean by compile safe, because if you use that in your query and, for example, the order date changes to purchase date, then your code will no longer compile if you regenerate the objects from your database table. What Juke also generates is records. Records is a one-to-one representation of the database table and represents a row in a table. So you can fetch data from the database and return, for example, a purchase order record. The point is this purchase order record is flat. So you don't have nested structure like you get if you're doing Hibernate mapping. So the purchase order record is just covering the purchase order database table without any relationships. That's very important. But you can use that, for example, to read the purchase order record directly. Then it's kind of managed like you have that in Hibernate. And then you can set an attribute over all the various getters and setters that you have here in this class. So we have like set customer order, set ID, set order date, all the fields can be set. And finally, because purchase order, here you see it extends an updatable record impl. An updatable record is kind of a active record pattern implementation. So you have a method, it's called store, for example, where Juke then will create an insert or an update statement, for example. So let's have a look at Juke in action. First, we have the command side. So I used Juke here to write the data. The base interface that you need if you want to work with Juke is called DSL context. Think about it like the entity manager when you use JPA Hibernate. It's kind of similar. And for example, if you create an order here, in that case, we can use the context here to create the SQL statement. So we have a select from, and here we see the metadata customer that is generated that we can use. And then we have like the where condition where we also use a column of the customer table called ID, and we here use the equal operator because we want to compare the customer ID with the customer ID that comes from the command. And importantly to say is that this is type safe. So customer ID, if I try to set a string, for example, then the compiler yells at me and says, oh no, that's not allowed because we only have long methods. So that means I have to provide a long. So this is also type safe. So we have compiled time safety and also type safety in terms of the types. Now, this is just to check. So we check if it exists or not. If it doesn't exist, we throw an exception. And other than that, we create a new purchase order. Here you see that the context also has a new record method. It's similar to calling entity manager persist. So you get a managed object here, and then I set order date and customer ID. And finally, I can call store, and store will, in that case, create an insert because there is no ID set. If the ID will be set, it will create an update, for example. By the way, Juke also creates minimal updates. So if you use the record and just change one field, then the update statement will also create just one update for one column. So you have a minimal update and not too much. We have similar stuff if you use add item, for example, and if you want to update the quantity, instead of loading the record and calling store, we can directly update the order item. And the result of an update or an insert is always the number of rows that has been changed. And if here in that case the rows are not changed, then we will throw an exception because the order item probably couldn't be found. So that's for the writing side with pure SQL in terms of Juke. Now let's have a look at the query. So the query that we have seen before, I can maybe take that and put it in the SQL editor here. Let's find that. Do it nicely formatting. And then we see that we have a select statement from purchase order with the join to customer and purchase order with purchase order customer ID. And then we see that we have something like a row. A row is a row value constructor as well. So it creates a row. And then we have JSON functionality to do the nesting. So the trick of Juke for the multi-set operator is to use JSON functionality that exists for a very long time to get back nested structures, because SQL is not able to return nested structures currently, but they're talking about that. So let's have a look at the repository. And here we see that we also have this with SQL, so this nested element. And let's go through the query. We select the order ID and the order date. By the way, the purchase order that is returned is a record. It's also a DTO, kind of a DTO. I just don't call it DTO because it's just purchase order. That's fine for me. The customer is also a record, and the order item is as well a record. And we have also then included the product. So the structure is more or less the same as with the traditional implementation, but this time in records and selected in one query. So because we want to have the customer separately in an object, we need this row value constructor. So this will create a row that we can map to the customer. We can use mapping here and pass a static reference to the customer constructor. And here you see something that Juke also provides. It's called implicit join. So Juke will generate also kind of method that is pointing to a table that is referenced in a one-to-one way. So we have a one-to-one or a many-to-one relationship between purchase order and customer. And Juke knows that because of the foreign keys, and it generates that code for us, so we don't have to write join. It's like if you use Hibernate with JPQL, you can also reference like a one-to-one relationship with the with the dot operator, for example. Then we use this multiset for the order items. And also here we have the row value constructor to create a product. We can also order, for example, the objects inside. So we order the order items by ID because this is probably the order as they were added to the purchase order. Then we have the where clause. And finally, we also have order by. We can set offset and limit. And then we fetch into something, and the fetch will do a mapping also here to the constructor of the purchase order. And this is also type safe, means it checks if the purchase order constructor accepts all fields as they are used in the query. And this finally results in this single query. Now we have seen the command handler. We also have seen the various queries or repositories to manipulate the data. The question is, I mean, for fetching, it's simple. We have get mapping with the customer orders. I used here a find orders object with all the information, first name, last name, offset, and limit. But I wouldn't have to do that. I could just use query parameters or request param annotation here in the REST controller to get that, so it doesn't really change. But the interesting part is how do we create the order controller or the REST controller for the order. There are two ways. I created two implementations. First of all, I created an order controller that has a request mapping orders. And this is very similar to a REST API because I use post for creating an order, post for adding an item, with also the URL with the order ID and the item. So it's kind of a RESTful API that as a request body has a command. I also have a patch mapping for updating the quantity, and I would have like delete mapping if I would implement the delete order item command, as I said before. So that's fine. So this is kind of RESTful. But on the other hand, I could go ahead and simplify that because I could say, oh no, I don't want to do that. I just want to have a single post request. And then I have a post mapping. Here it's create order. That's probably not the right word. So let's call it post. And this gets an order command. And this just delegates to the command handler. And that's it. So we just added a REST controller in front of our command handler with a single method. Now, maybe you have seen it already when I showed you the order command. I use Jackson annotations to do inheritance. For the order controller, the regular one, I wouldn't need that because every method has its specific command. So per command, I have a REST controller method. So it's perfectly fine. I don't have to do anything. But the command controller receives an interface. And now Jackson needs to know which interface should be created for this input. And for that, we can use JSON type info. And JSON type info, you can define, for example, how the ID should look like. In my case, I say the ID is a simple name. So that's the simple name means that's just create order command, add order item command, or update quantity command. And then I define the subtypes that I have here. And this means my request would look a bit different. So I have here, for example, a post request to create an order. And as you can see, I have here a special attribute. It's called add type for Jackson. And then I say here, that's a create order command. And then finally, it will create the customer ID. And by the way, just to show you, this also, let me check. That's, yes. If you look at what Swagger generates for that, we also have the order command controller. So here you see the order controller, orders, everything fine. And here we have just a post. But we see that the schema that we get here is not order command, create order command, or update quantity. So also here we have this information about the, the, um, the hierarchy of our commands. Cool. So to conclude, for our project, it was very beneficial to split commands and queries because this improved the understandability of the code, not only on the server side, but also on the client side. Over and under fetching are no longer a topic because on the command side, you only send the minimal data that you need to execute the command. And on the query side, you define query methods that fit exactly what the client needs in that case. So you don't have over and under fetching. And depending on your persistence layer, for example, if you use Juk, then mapping for the DTOs will be obsolete. So you probably don't need Mapstruct or model mapper to map that. You can create directly the query to do that. And if you really want to go into CQRS full in, then you will end up with probably with that one, where you can split the read and write model also in the database. For example, if you have nested structure that you would fetch, you could store them in a SQL database and then over a mechanism, for example, with events or whatever, you could populate, for example, a MongoDB that is document based, and you will get directly the data back without any need to map um, for, for the query. But that's all in. As I said, you also can start simple, just split command and queries. And that's it from my side. Thank you very much. Are there any questions?
Thank you so much, Sir Simon. Thank you so much for that very informative presentation. I'm sure that our participants here this afternoon have learned a lot from that presentation. And so, guys, why don't we show our appreciation to Sir Simon with those clapping and heart emojis, please? Virtual claps and virtual hearts. Show the love. And because of that, sir, I believe we do have a lot of questions for you here posted. Let me just read them one by one for you, and then we'll just raise it to the stage screen so that you can easily also read it if you might need to. So the first question is, CQRS can introduce complexity. What factors would you consider when deciding if CQRS is the right approach for a Java project? And when might simpler architectures be preferable?
That's very easy to answer. As always,
Mhm.
it depends. Now, the point is, if you have a very simple application, you have more or less create, read, update, delete, CRUD as the application, you probably don't need CQRS. It would be simply an overkill. But there, the question is also, do you really need like DTOs and distinguish between DTOs or entities, or can you directly return the entities? By the way, there are other solutions that maybe you have a database and want to just create the CRUD application on top of it. You maybe even don't need to write a lot because Spring Data, for example, has Spring Data REST, and you can create directly REST APIs from your Spring repositories. So that would be the most simple solution in terms of Java. But CQRS is clearly something for a bit more a bigger or a medium-sized application, not for something very simple.
Yeah. So actually, the next question coming from Colleen actually asks for the specific types of projects. So what types of projects does CQRS provide the most benefits?
I think the most benefits are for projects that have a huge API and they are bound to, for example, a single page application, as I've introduced my problem with the client server communication. And that is very beneficial because for the point is, or the problem with single page application frameworks is often that also the project team is split or the team is split.
Mm-hmm.
So you have backend developers, you have front end developers, and sometimes the backend is created before the front end. And that's not a good idea because then the front end team will probably work around the API and not fully have the perfect API that they would deserve to build the application. So, I
Mm-hmm.
mean, if you really have single page applications, something that I didn't mention, and if you read the CQRS documentation from Greg Young, you will find out that Greg is talking about task-based UI. So if you have CRUD, you just have a UI, then you type in data in a huge form and save. But if you do CQRS and you do commands, you maybe want to split your application into more a task-based UI where you have like a wizard to create data, for example. And this would also be beneficial in terms of the user experience, probably that the user has more like a guided way through the application and not a huge form where he has to know everything on the form
Mm-hmm.
directly.
Thank you, Sir Simon. Colleen, I hope that answered your question. Our next question from Rachel Ann. What best practices should be followed for testing and maintaining a Java application that implements CQRS?
If you look at my application, on the demo application, I created tests. By the way, there are also tests. So for the Spring controllers, I just use like MEC test from the Spring framework. Um,
Mm-hmm.
in my opinion, it's not different from other applications. So you have an API test and query test and command test. It's the same as you test post, get, put, delete. So it doesn't matter if it's a command or any other that thing that you send over the wire. But on the back end, it will become easier, maybe, because you really can concentrate on the query side to test and tune the query side that it's very performant and it fetches exactly the data that you need and not too much and not too less. And on the command side, you have commands. So commands are also easy to test because they follow kind of a functional way. You get a command into the command handler, and from that you can test it. So it's much easier to create a command for testing than creating a whole DTO with all the information
Mm-hmm.
probably test.
Thank you, sir. Thank you, Sir Simon, again. And Rachel Ann, that was a wonderful answer to your question, right? So our next question, from Chris, what are the pros and cons of CQRS in modern Java?
Yeah, the process, as I said, it really adds understandability to the code.
Mm-hmm.
So in my opinion, it's easier to understand what happens. But the cons are sure you have you don't have two models to maintain. That's probably not the right thing. But you have to maintain two parts of your application. So you have the content side and you have the query side. But in the end, it's not that much more effort. But if you're going full into CQRS with two data sources for command and query, then you have more effort because you have to maintain and also operate two databases. So that's probably a downside of this approach
Mm-hmm.
if you full in.
Thank you, sir. Another good question we have here is, with modern Java frameworks constantly evolving, are there any specific frameworks or libraries you see as particularly well suited for building CQRS systems today?
No, it doesn't really matter. So you can
Mm,
choose anything. It's Spring Boot, Quarkus, Helidion, Micronaut, Vertex. It
mm-mm,
really doesn't matter what you choose because CQRS is a pattern on a conceptual or architectural level. So it doesn't has to be implemented the way I did it. I just did it because I'm fancy the new Java features and like to show you how you could create a command handler with that. but it really doesn't matter which framework you're using.
Thank you, sir. Thank you for that answer to the question. Our next question is, what are some of the biggest challenges you've encountered when implementing CQRS in a Java project, and how did you overcome them?
The problem is the mindset of the other developers. So first you have to explain why do you do that, and then you have to show examples how it could be beneficial. So if you want to start with CQRS, it's you have to explain, you have to teach also the other developers, or show them that maybe they have some if they heard CQRS, they have this picture in mind with a complicated structure, and you have to tell them that you can start simple. So that's the first point. If
Mhm.
you're already started to work on the project as we did, and you face the problems that the API is not fitting the needs of the UI, for example, then it's easy to go into the idea of splitting commands and queries also in the API.
Thank you, sir. Our next question, um, this is quite specific. Sorry, my dog is
No
barking in
problem.
the background. I'm so sorry. So the next question, according to my dog, will you confirm please that CQRS would require you to maintain two repository instances for command and query, or do we make a differentiation of query and command business logic?
Now I would absolutely split that. So I
Mm-hmm.
was talking about DDD because very often today we use domain-driven design to create the application. We go into maybe a hexagonal, onion, or clean architecture style where we want to protect our domain. And in my
Mm-hmm.
opinion, this all is fine, but this belongs to the command side. So usually you have a command, and the command will change the state of your domain model. And then
Mm-hmm.
somehow finally, the database will be updated, but the query side I will keep completely separated in the code. So own repositories, own DTOs, and not mix the two. So that's very important, and this is also the benefit because then the query side will be much faster, and that's a good thing, or the pro of this approach.
All right, thank you, sir. Another question here is, do we have concerns in terms on synchronous events for CQRS? For example, finishing the activity first before being able to get a new request.
I know what you mean. Yeah, that depends. It depends a bit on how you create your commands or how fine-grained you create your commands. So if you have really like a workflow, create something, add something, and this has to be done very fast or more or less together, because as you said, you were waiting, then maybe it's not a single command. So maybe you can, or then it's maybe a single command and not multiple commands to do that. But
Mm-hmm.
usually CQRS or the commands are used, for example, in a single page applications. There you have the user, he has to think, right? So he's not that
Mm-hmm.
fast in adding items to the basket, for example. So this really takes a while when he does that, and usually you don't have this problem. And this is also part of the client side to handle that. So
Mm-hmm.
you can't send, for example, the create order and an order item command in parallel. This doesn't make sense because you first have to create your order and then you can add the items. So yeah, it depends on the requirements.
Mm-hmm. All right. I hope that answered your question. Our next question is actually, I believe this is kind of related to the previous question before the most recent question that we had. So Kim is asking, when implementing CQRS using modern Java features like records and pattern matching, how do you ensure efficient data access while maintaining clear separation between commands and queries?
Mm.
So
Yeah,
right,
the
it's kind of
command
yeah.
on one hand is simple. So in the simplest form, the command just creates an insert or an update or a delete statement, right? So that's the command side. Depending how complicated your domain is, you will have domain model, and so that's no different from any other application. On the other hand, the queries, as I already said, are much faster because they are dedicated to just that query request. By the way, just as a remark, on the query side, you could also use something like GraphQL if you have a lot of queries and don't want to create the query per requirement from your client. So this depends a
Mm-hmm.
bit. But if you're doing as I did it with Juke, for example, or also with Hibernate, you will have queries that only access the data that you really need and also return only the data that you need. So you have a much better performance on that side. And no entities involved. So you don't need
Okay.
entities to fetch the data.
Yeah. Thank you for that answer, sir. I hope, Kim, that answers your question clearly. Another question. I think I read two questions that are typically similar. But it mostly goes, how does CQRS help improve scalability and performance in Java applications? The other question actually specifies about Java applications that handle large volumes of data. So
Yeah.
you can just answer both questions.
The point is, if you really split, or let's assume we go full in CQRS, we split command and query model, then it's very
Mm-hmm.
beneficial because you can have massive load on the writing side and you can have
Mm-hmm.
massive load on the reading side. They are simply split, so they do not affect the same database. For example, you can tune or use the database that is best for writing for the command side, and you can use the database that is best for the reading side. But keep in mind, if you go in full end with QQRS and use events, for example, to update the reading side, then you have eventual consistency, and
Mm-hmm.
your application has to deal with that, or your users have to know that you may have eventual consistency in your system. But CQRS is really, if it's fully implemented, is really used to improve scalability and performance.
Mm-hmm. All right. Thank you once again, Sir Simon. Thank you so much for answering our questions. And thank you so much for joining us this afternoon, all the way from Switzerland. We really appreciate you sharing your expertise today. And now, in case you guys still have a question, I think you can still have a quick chat with our speaker on here in
Sure.
the platform on AirMeet. And but unfortunately, that's all the time that we have for today. If you enjoyed this session, please give your rating and share your feedback about our speaker and about your whole experience of the session and the entire AirMeet platform. You'll find the link in the chat box, as you do in every session. So again, let's thank Sir Simon for joining us and for sharing his knowledge here with us. Let's shower him with a lot of applause and hearts, please. All right. So once again, thank you, everyone. Thank you, Sir Simon. You may now proceed to your next session, guys. You can exit the session and go to your next chosen session. Bye, guys. See you next
Thank you very
session.
much. Bye.
Thank you, sir. Thank you so much.